Now next property, property number 8, it says that in a determinant you can apply a certain operation. What that operation is, you can take any one row. For example, I am saying row number 1. So it is R1. On row 1 we are taking, what I am doing here, in row 1 I can add k times of R2. This is first row. In this, I am just adding the elements of second row by multiplying it by k. So this element will multiply with k and add it here. This should not change. Only the elements of these will be taken in consideration, multiply them with k and add it in first. This operation will be written by this R1 as R1 plus k times of R2. Then what this will become? This will be A1 plus k A2. B1 plus K B2, C1 plus K times of C2. This is A2, B2, C2, A3, B3, C3. Now you will find these are nothing new. This matrix is equal to this. I can prove it easily. We have done certain properties. I'll use those properties and just check whether this is getting or not. We are getting this result or not. One property I told you that if any row or column is a sum of two elements, we can split this in two parts. What is that? A1, B1, C1, A2, B2, C2, A3, B3, C3 plus. What it will be? KA2, KB2, KC2. And here it is A2, B2, C2, A3, B3, C3. Can I write this property? Already I told you. And then one thing I told you that common should be taken row wise and the column wise. So in this case, this complete row gives you k common. So I just take out this k from here, will become k times. Now you check this matrix. In this matrix, first row and second row are becoming identical. And as soon as these two become identical, we will say this part is completely zero. Because I told you in determinant, if any two rows or any two columns are identical, the result come out to be zero. So that means this part is clearly zero and this will be the part left here, which is same as this matrix. So this type of operation you can operate. R1 if you are taking, that means R1 remain unchanged. In that you can take k times of some other row, or you can take this column 1, then column 1 plus k times of column 3. This is not going to change. Second column or the third column will multiply with some number and will be added in the column 1, then the result is not going to change. This is very important property. Most of the question you will be using this property, that you should keep in mind. Next property, property number 9. Ninth property says that if you have a diagonal matrix, this is 2, 3, 4 diagonal matrix. I told you this is a matrix in which the leading diagonal elements are not necessarily 0, but all other element will be 0. And if I say you find out determinant of this matrix A, I want determinant of this matrix A, then simply what you should do, multiply the diagonal element. That will be 2, 3, 4. That will be 24. But this is only for the diagonal matrix. So whenever diagonal, this can be in 1 mark question, that diagonal matrix is given to you and then they will ask what is determinant A. They can write this also. DIG, that is a diagonal element, 2, 3, 4. This is diagonal matrix. This is diagonal matrix. It is also written in this form. And if they ask you find out determinant of this matrix, then simply the diagonal element should be multiplied and you will get the diagonal determinant of A, right? So this you should keep in mind. Next property. Next property says that if you have a matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. This is one matrix A. And another matrix is C. C will be the matrix of their cofactors. That is C11, C12, C13, C21, C22, C23, C31, C32, C33. One matrix multiply with this cofactor. What I want in this case? We want multiplication of this matrix, cofactor matrix. If I take this cofactor matrix, multiply with A transpose. If any matrix you take and that multiply with its transpose, just check what the result comes. Matrix multiply, this is cofactor matrix, multiply with its transpose. Cofactor matrix is C11, C12, C13, C21, C22, C23, C31, C32, C33, and then transpose. So it will be A11, A21, A31, then A12, A22, A32, then A13, A23, A33. If I just multiply these two matrices, what I'm doing here, A matrix is there, then it's cofactor matrix. I multiply cofactor matrix with the transpose of A matrix. Now when you solve it, just check what the multiplication comes. This multiply with this. So will it come A11 into C11 plus A12 into C12 plus A13 into C13. Then this multiply with this. This will come A21 C11 plus A22 C12 plus A23 C23. A23 into C13. And the third one will be this multiply with this. This way it will continue. Now I'll just tell you the result here. Just check here. These are the elements and these are their cofactors or no. A11, C11, A12, C12, A13, C13. Element multiply with their cofactor. I told you element if multiply with their cofactor, the value always come out to be determinant A. That means this will be nothing but determinant A. When you take second, this is second term. These are the elements, these are the elements, these are the cofactors. These are cofactor of first row and these are the elements of second row. So if these are not matched, what the result come out to be? 0. So if element are not multiplying with their corresponding cofactor, they are multiplying with the cofactor of some other row, result is 0. Now check. This if multiply with the third. These are elements, cofactor of first row. These are elements of third row. Right? They are not matched, so the result is 0. Then this is second row cofactor. These are element of first row, so this is 0. This if you multiply with this, now this is second row cofactor. These are second row element. So yes, this is giving determinant A. Same with this. If multiply with this is second row, this is third, so it will be 0. Then this is third row cofactor, element of first row, 0. This is third row, second, 0. Third row, third element, yes, so determinant A. So we are getting one result now, CA transpose is this. Is this clear? Now from this, one more result I got. Can I take determinant A common from all? Because matrix is there, so common will come from all and all are 0. So this can give determinant A common. Left is 1, 0, 0, 0, 1, 0, 0, 0, 1. And this is CA transpose. Is it right? Now, is it your identity matrix? Is it also a diagonal matrix? So if I say I3 1 0 0 0 1 0 0 0 1, then if you take determinant of I3, will it be 0 or 1? 1 because the diagonal element are 1 into 1 into 1. So I3 is coming 1. Now I take this CA transpose is determinant A into I. Is this clear? Now, if I take determinant on both sides, now what I'm doing here, I'm taking determinant on both sides. So when I take determinant on both sides, it will come CA transpose is equal to determinant A into I. Yes or no? Then one property already I told you, determinant AB will be determinant A into determinant B. So I'll write determinant C, determinant of A transpose. And this is determinant A, I. Is this okay? And after this, one more thing we have done, determinant A is determinant of A transpose. So determinant A is equal to determinant of A transpose. So determinant C into determinant A now. And here, very important result. Determinant A into I if I take. Determinant A is a number. So when I take determinant A multiplication, what this will come? This will come determinant A 0, 0, 0 determinant A 0, 0, 0 determinant A. Right or no? This is AI3. Now I want determinant of this. Is it I3? AI3? This is AI3. So when I take the determinant of this, I'll get determinant A 0, 0, 0 determinant A 0, 0, 0 determinant A. Now as determinant is here, so common should be taken row wise. So how many determinant A will go? One from this, one from this, one from this. So determinant 1, 0, 0, 0, 1, 0, 0, 0, 1. And we have already done that this determinant value is always come out to be what? 1. So will it come out to be determinant A cube is determinant C into determinant A. So here keep in mind cofactor matrix determinant value will be square of determinant. This is another important property. Determinant of C is determinant of A square. Cofactor matrix, if you take and its determinant you want to calculate, it is nothing but determinant of A square. That you should keep in mind. So these are the properties we have finished. In next class, I'll take these properties with help of, we'll use this or we'll say the application of these properties I'll take in next topic. So next time we'll continue. Thank you.